Hello everyone. In this video I would like to demonstrate a web application which we build on top of Fair Data Point. This is a web application which we built for rare disease researchers. This application combine data from different biobanks and patient registry and answer some of the commonly asked questions in rare disease world. Here you see the architecture of this web application. On the top you see a web client which is connected to a backend. In our case is connected to a link data store. The content of this link data stores are coming from different biobank and patient registry Fair Data Point. This is a web application I'm going to demonstrate today. So here in the top you see a list of predefined queries which we obtain from different researchers from rare disease world, and when you click one of this query you get a form to fill in. So in the query which I clicked, I'm looking for number of biosample from a donor with particular phenotype. So the query require phenotype as an input. So if you select a different query, then you get a different form to fill in, and the form which you get it based on a number of parameters that you supply to answer that particular query. So I already preloaded this demonstrator with some data. So I would like to answer this query where I would like to get a number of biosamples from a donor with particular phenotype. So I'm going to select a white mouth as a phenotype, and when I click process, I get a result table here where my demonstrator suggests it finds 6 biosamples from this particular biobank. By the way, all this blue text are clickable links. So if I click the biobank link, I get some information about a biobank. These are metadata information about this particular biobank, which contains biosamples about wide mouth, and these informations are coming from a tool called ID card, which is a tool in a rare disease world which collect information about different biobanks and patient registries related to rare diseases. So when I click the phenotype link, I get a redirect URL which points me to white mouth concept from human phenotype ontology, where you get more information about white mouth concept. And this particular ontology also has a nice hierarchy. Let's see what happened if I select one of this upper concept as an input for my query. Just select abnormality of head and neck as input. When I do it, I get a result table where you see a number of different phenotypes related to head and neck or reporter. So I see wide mouth is reporter, also see abnormality of teeth as reporter in my result. So what you see here is a query simply making use of the hierarchical structure. So instead of taking a head and neck as an input, it took all the subclasses of head and neck as an input and executed the query. And here you also see you get results only related to one particular disease. In this case we get results related to Angelman syndrome, based on the previous interaction with rare disease researchers. I also noticed that ring 14 clinical database might contain some information about biosamples for some of the phenotypes that I'm interested in. And also understood from rare disease researchers, this particular ring 14 database is also published in Fair Data Point. So in order to look for data sets that are published in a Fair Data Point, you can use this tool called Fair Data Search, which simply indexes metadata from different Fair Data Points, and the user can search for data sets that they are interested in. So I'm interested in ring 14 database. So when I search, when I enter it in a search box, I get a result. So this in this particular Fed data point, the ring 14 clinical data set is described. So this is the landing page of that particular Fed data point. So where you get like some metadata information about that particular Fed data point, and this Fed data point contains 2 catalogs. When I click one of those catalog, I get like more information about that catalog. So I get like you can see it like it's a catalog about disease registry, and this particular catalog contain like 2 data sets. When I click one of those data set, and I get like more information about that data set. So in this case, like I get information about like a ring 14 clinical database, and this particular data set is distributed in 2 formats, as a HTML page and like as a turtle format. When I click one of that, then I get like more information about that particular distribution, and this is a turtle distribution, and we can download like the content of this database via this link. By the way, the information in these links are like mocked up link. It's not like real data, it's just mocked up data. So when I provide like this as a input to demonstrator, so I'm basically asking demonstrator to index like all the metadata information from this particular Fed data point, and also if some of the data sets is distributed in a turtle format, I'm also instructing my demonstrator to index those turtle files too. So I provided a link, I gave a name for this particular Fed data point, and when I hit like a cache button, all the metadata information are indexed now. So when I go back and execute like the first query again, so when I select like abnormality of head and neck as an input and process it, now I get like more results, and now I get like results which are reported for like ring 14 disease as well. And this is what I would like to show in this demonstration, and thanks for watching it.